Okay, so today's lesson is over 3.2 angles and parallel lines. So yesterday we talked about angle pairs formed by parallel lines and some transversals. Today we're going to use theorems to determine the relationship between specific pairs of angles, as well as use algebra to find angle measurements. We're going to talk a lot today about parallel lines that are cut by a transversal. So I know we talked yesterday, but about what parallel lines are as well as a transversal. So getting started here, first one up is the corresponding angle postulate. So we're going to learn basically about all the angle relationships we learned yesterday, and we're going to learn what these angle relationships look like if we have parallel lines. So as you can see here from these pink arrows that are going on these lines, we can see that these lines are in fact parallel. And we would still have some corresponding angles. So just like yesterday when we talked about corresponding angle, we said one on the outside, one on the inside, and they are on the same side of our transversal. So if you couldn't tell already, this horizontal line here would be our transversal. And let's say if we took angle 1 here, angle 1 is on the outside, and I wanted to find an angle that corresponded to angle 1, it would be angle 3 here. So in corresponding angles, whenever our lines are parallel, remember, only if our lines are parallel, our corresponding angles are congruent. Okay, so angle 1 is congruent to angle 3. Angle 8 would be congruent to angle 6. Angle 8 congruent to angle 6. Likewise, angle 2, angle 4. Angle 2 is going to be congruent to angle 4, as well as angle 7 and angle 5. So you can see these angle relationships here. Remember, anytime that we have corresponding angles and our lines are parallel, okay, lines have to be parallel. That is the most important part of this. If our lines are parallel, then these angles are congruent. Okay, so if our lines are parallel, corresponding angles are congruent. Likewise, alternate interior angles and alternate exterior angles have the same exact thing going on here. So alternate interior angles we learned about yesterday, that would be like angle 1 and angle 3. Since these two lines here are parallel, our alternate interior angles are also congruent. Okay, so 1 and 3 are congruent, 2 and 4 are congruent. Alternate exterior angles are the same thing, right? So we know that 5 and 7 are alternate exterior angles. And since these lines here are parallel, we can say that our alternate exterior angles are congruent. And again, I want to make sure we all understand the reason that we can say this is because we have parallel lines. If these lines were not parallel, we would not be able to say this, okay? And the last one here, consecutive interior angles. Again, this is if and only if we have parallel lines. But these are not going to be congruent like the rest of them. So every other angle relationship we talked about is congruent. So corresponding alternate interior, alternate exterior, all three of those would be congruent. The only one that is not is consecutive interior. Okay? And consecutive interior angles are supplementary. Okay? Angle 1 and angle 2, those would be consecutive interior angles because they are both on the inside of our two lines, and they're on the same side of the transversal. These angles here will add up to 180 degrees. So if you have consecutive interior angles with parallel lines, those are supplementary. Okay, let's get into it here. So some examples. In the figure, the measure of angle 11 is equal to 51. And the measure of angle 15 is right here. We need to find the measure of angle 15, and we need to state which postulate or theorem we used. So what we need to do is we need to come up with an angle relationship for 11 and 15, and then we need to ask ourselves, what is the case for that angle relationship? So looking at 11 and looking at 15, looks like one's on the inside, one is on the outside. So that tells me if they are on the same side of the transversal, they are going to be corresponding. So these are corresponding angles. And now we need to go back to our notes here to figure out what we know about corresponding angles. So here's our corresponding angles postulate, and it says when we have parallel lines, our corresponding angles are congruent. So since these angles here are congruent, I can say angle 11 is congruent to angle 15, right? And since angle 11 is 51, that's going to equal angle 15, okay? So we can say that the measure of angle 15 is equal to 51 degrees. Again, I apologize for this pen. Okay? All right, let's move on to the next one. So in letter B here, we got angle 11, which is again 51. And we need to find the measure of angle 16. All right, stating which theorem or postulates we used. So again, first thing I want to do is come up with some sort of angle relationship. What is going on between angle 11 and angle 16? Hopefully you guys are able to see these are in fact alternate exterior angles. So let's go back and figure out what we know about alternate exterior angles. Right here, alternate exterior angles, it says if we have two parallel lines cut by a transversal, that alternate exterior angles are congruent. Okay, so knowing that these are congruent, we're going to do essentially the same thing we did in the previous question. So we are going to say angle 11 is congruent to angle 16. And we're going to say here that the angle 11 is 51. So we can say 51 is equal to angle 16. And our final step here, I'm just going to write it out real pretty, just like the way the PowerPoint is asking. So the measure of angle 16 is equal to 51 degrees. Okay. Moving on here. Got this example. If A and B are parallel, it's a good thing they tell us that because there are no arrows to show that. And the measure of angle 18 is 42. Find the measure of angle 22. So I want you to go ahead and pause right now. I want you to come up with an answer, whether it's A, B, C, or D. Okay, so what I want to do is I want to think about what type of angles do we have here. One on the inside and 22, one on the outside and 18. They are, in fact, on the same side of the transversal, which means they are going to be corresponding angles. Oh my goodness, this is rough. I apologize. Okay, so since these are corresponding here, we know that that means that they are congruent. So if angle 18 is 42, that means angle 22 must also be 42. Okay, now in the figure, we get the measure of angle 18 again is equal to 42. We need to find the measure of angle 25. So go ahead and pause it again. Alrighty, so hopefully you were able to tell these are alternate exterior angles. The reason they're alternate exterior angles is because they are both on the exterior and they're on opposite sides of our transversal. So we got 42 for angle 18. We got to figure out what we know about alternate exterior angles. We know that alternate exterior angles, when our lines are parallel, are congruent. So if angle 18 is 42, that must mean that angle 25 is also 42. All right, next slide here. So it says floor tiles here. The diagram represents the floor tiles in Michelle's house. If the measure of angle 2 is 125, find the measure of angle 3. So let's think about how we're going to do this here. If the measure of angle 2 is 125. We need to find the measure of angle 3. So if we look at these, let's look at these two lines that are running horizontal. Let's look at these two lines here, the lines that are running horizontal. So if we look at these two lines, is there a line that connects both of these lines? Is there a line that connects this top line to this bottom line. And hopefully you said yes. Hopefully you saw it's going to be this middle line right here that connects both of our lines here. So we call this the transversal. Anytime we have a line here that is going to basically connect both of our red lines to create some angles between the two, that is the transversal. So let's look at angle 2. Let's look at angle 3. What type of angles would these be here if this green line T is our transversal? So it looks like here those both would be on the inside. So since these are both on the inside here, I know it's going to be some sort of interior. They appear to be on the opposite sides of our transversal. So these are going to be alternate interior angles. And again, let's ask ourselves, what do we know about alternate interior angles? Well, we know that they are congruent. So if the measure of angle 2 is equal to 125, that means that the measure of angle 3 must also equal 125 degrees. All right, let's move on now. So this question here, it asks us, if the measure of angle 2 is 125, just like it was in the previous question, then what is the measure of angle 4? So there's a couple different ways to do this. Let's just pretend that we have no idea what number 3 is. I know we found it in the last question. Let's just pretend we don't know what it is. In this scenario, I'm going to ask you, is there any relationship between angle 4 and angle 2? And hopefully you're sitting at home saying no. There is no relationship between angle 4 and angle 2. That's correct. There's not any angle relationship there. Now, what if I asked you angle 1 and angle 4? What is the angle relationship between angle 1 and angle 4? Hopefully, you guys are at home saying alternate exterior angles, right? Alternate exterior angles. So we know that alternate exterior angles are equal. So if we can figure out here what angle 1 is, then we're going to know what angle 4 is, right? Now, in order to figure out what angle 1 is, the only measurement we have to go off of here is this 125. So when I look at angle 2 and angle 1, there's something I noticed about these two angles. It appears that these two angles here form a straight line. So they are a linear pair. And if you know anything about linear pairs, you know that these two angles here will add up to 180 degrees. So angle 1 plus angle 2 is actually going to give us 180. Okay. So if we want to solve this for angle 1 here, we'll plug in what we know angle 2 is. So angle 1 plus 125 is equal to 180. And we will subtract 125 from both sides. I promise I'm not writing this poorly. So we're going to get here that angle 1 is 55. So if angle 1 is 55, we've already talked about it. Angle 1 and angle 4 are alternate exterior angles. So we would be able to solve this. And we know since alternate exterior angles are congruent, if angle 1 is 55, then angle 4 must also be 55. All right, moving on. So it says find all the missing angles if A is parallel to B. So if A is parallel to B. So let's just say, for example, that this is 70. So we're going to start off here with 70. Now I want you to pause this, go through and see what you can come up with. I'll be very interested to see if we're able to make this work. So go ahead, take a pause, and try to fill this out. Okay, so I'm gonna use multiple different types of angle relationships here, and I'm gonna explain those as I go on. So the first thing I want to do is I actually want to use something we learned in chapter 1, which is vertical angles, right? Angles that are right across from each other when we have two intersecting lines. So if the first angle here, this top left angle, is 70, I know that this angle right here will also be 70 because of vertical angles. And now what I want to do is I'm going to jump to alternate interior angles. So I'm going to go, hey, this is 70. Which angle is alternate interior to this angle? That would be right here. So this is 70 as well. And now over here, if this is 70, we know that this is vertical to it. So this is also 70. And over here on the right side here, these two angles here form a linear pair. So at the top here, we know that these form a linear pair, which means they add up to 180. So this is going to be 180 minus 70, which is 110. And then basically, we can just fill this out the rest of the way. So vertical angles, alternate interior angles, vertical angles. All right. Now, we would not be able to fill out this line just based on the information that I gave you. So since I said that this is 70, that doesn't necessarily mean anything over here. And if you're asking why, it's because these lines are not parallel. So let's give these some names. If those are A and B, let's call this L and M. L and M are not parallel, right? So we cannot say the same thing about L and M as we can say for A and B. So if we wanted to know what these were, we would actually have to start off with a new number. So I would basically just have to tell you, hey, that's 60. Go ahead and find everything else. Okay. We're not going to go ahead and do that just because we did the left side. I want to keep this a little bit shorter. So we're going to move on to the next slide. Okay. Right here, we got some algebra. So it says the measure of angle 5 is 2x minus 10. And the measure of angle 7 is x plus 15. And we need to find x. So first thing I notice here is our parallel lines. So all four of these lines are actually going to be parallel. But we can kind of think of P and Q are our two main lines with M as our transversal. Okay, M is the line that connects both of these angles because both of these angles lie on P and Q. So let's ask ourselves, what type of angle relationship is angle 5 and angle 7? So hopefully you can see one's on the inside, one's on the outside. They're both on the same side of our transversal. These are going to be corresponding. I think I might retire this pen. Okay, so since these are corresponding, what do we know about corresponding angles? Well, corresponding angles are congruent. So we can say that angle 5 is congruent to angle 7. And if these two are congruent, then we will take their algebras, plug them in, and set them equal to each other. So 2x minus 10 is equal to x plus 15. All right, from here, get rid of your smaller variable first. So this is going to be a minus x on both sides. So x minus 10 equals 15. And here we're going to add a 10 to both sides. So x equals 25. All right. Moving on to the next one. If the measure of angle 1 is 9x plus 6, and the measure of angle 2 is 2 times 5x minus 3. The measure of angle 3 is 5y plus 14. We won't worry about that just yet. So here are our two lines. Our two lines that we're going to focus on are A and B. Our transversal is going to be line C. I want you to get used to asking yourself, which line is the transversal after every question. Okay. And the reason I know that C is the transversal is because A and B are the two lines that C goes through to make angle 1 and angle 2. So hopefully here you're asking yourself this question, what is the angle relationship between angle 1 and angle 2? Hopefully you're able to see those are alternate exterior angles. Okay, those are alternate exterior angles. So we're going to go ahead and take 9x plus 6, and we're going to say 9x plus 6 is equal to 2 times 5x minus 3. All right, now algebra-wise here, we're going to need to distribute. So this is going to be 9x plus 6 is equal to 10x minus 6. So subtracting 9x from both sides, we'll get 6 equals x minus 6. And we will add a 6 to both sides. And x will equal 12. Ho, 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 that was rough. All right. So let's skip past this, skip past this, skip past this. Last thing I want you to look at here, there's no questions over this, but just so you guys have an idea, this is the perpendicular transversal theorem. Anytime we are given two parallel lines, like line A and line B, and our transversal makes a 90-degree angle, if our transversal is perpendicular to our parallel lines, that's going to create multiple right angles, okay? Just like these are corresponding, well, if one of these is 90, that means both of them are 90. So if A and B are parallel, line A is perpendicular to line T. Line B is also perpendicular to line T. All right. If you guys have any questions, feel free to send